Captions in English, please. So this video is the first video on chapter 5, and chapter 5 is on nomenclature. Nomenclature means how to name compounds. So chemists have developed systematic ways to name compounds, and that's the system we call nomenclature. If you learn the naming rules, you can examine a compound's formula and determine its names, and vice versa. If you know the name, you can retrieve the formula. So this way there is no mistake, there is only one name for one formula. But many compounds also have a common name, and water, for example, has the common name water, and the systematic name is dihydrogen monoxide. But water is such a familiar compound that everyone uses its common name and not its systematic name. Common names can be learned only through familiarity. There is no system. So another common name that you may learn this quarter is ammonia, NH3. So naming ionic compound. The first step in naming an ionic compound is identifying it as one. So remember, anytime you have a metal and one or more non-metals together in a chemical formula, you can assume the compound is ionic, because ionic compounds are made of cations, positive ions, and anions, negative ions. And the metals tend to make positive ions, the non-metals tend to make negative ions, and the attraction between the positive and negative charges creates the ionic compound. You may also have polyatomic ions that form an ionic compound. So ionic compounds can be categorized into two types depending on the metal in the compound. So the metal, the cation, can be type 1 or type 2. Type 1 metals are those that form only one type of cation, and the type 2 metals are those that form different cations that will have different charges. So the type 1s are metals that have predictable ions. So type 1 ionic compounds contain a metal with an invariant charge. It's a metal that does not vary from one compound to another. It will always make the same type of ion. And those are what we call also predictable ions. Type 1 metal ions are those formed from group 1A. We know the alkali metals always make +1 ions, like lithium, sodium, potassium, rubidium, and cesium. Group 2A, the alkaline earth metals, form always 2+ ions, so beryllium, magnesium, calcium, strontium, and barium. Group 3A, so beyond the B groups, you have the group 3A and only the metals. So boron is not part of these metals. It's a metalloid. So the metals from group 3A that make always 3+ ions are aluminum, gallium, and indium, always 3+ ions. And then there are also type 1 metal ions in the transition metals, but these are exceptions. The transition metals tend to make variable charge metals, but there is a few exceptions, which are cadmium 2+, zinc 2+, and silver 2+. And so these, you will have to remember these. Silver, zinc, and cadmium, always the same kind of ion. So naming binary ionic compound containing type 1 metal. So what does it mean, a binary compound? It's compounds that contain only two different elements. So there is two different symbols in the formula. And the name for binary ionic compound containing a metal that forms only one type of ion have the form. So first, it's the name of the cation, which is the name of the metal, just as it is in the periodic table. And then you follow it by the base name of the anion. So the anion is the non-metal. So you take the root of the name and you change the ending to "ide". And since the charge of the metal is always the same for this type of compounds, we don't need to specify the charge, in the compound name. That the reason why we say that it's because for the variable charge metals, you will have to specify the charge in the name, but not for the type 1 metals. So now the base names for the anion portion of the ionic compound are as follow. So fluorine, the base name is fluor, and you change the ending to "ide", and that's fluoride. Chlorine, the base name is chlor, and you change the ending to "ide", and that's the chloride ion. Bromine, the base name is brom, and it becomes the bromide ion. Iodine, so the base name is iode, and then with the "ide" in the end, it's iodide. Nitrogen, it's the base name is nitre. You remove ogen, so that becomes the nitride ion. Phosphorus, be careful, it's not phosphoride, it's phosphide because the base name is just phosphor, and then you add the "ide", and that's phosphide. Oxygen, remove the egen, and it's ox, and it becomes the oxide ion. Sulfur, again, it's not sulfuride, it's you remove the UR and it's sulf, and with the "ide" it's sulfide. Hydrogen, hydr, hydride. Again, you remove the ogen and it's hydride. So there is very few nonmetals, right, that make anions, because the noble gases are nonmetals that do not make ions. So that's pretty much the whole list of anions names that you have here. So let's go through some examples before you practice that. Naming type 1 ionic compound. First example, NaCl. So you may recognize the sodium, Na, it's the cation, it's the metal, and then Cl is the chlorine, and that's going to be the anion because that's the non-metal. The name for NaCl consists of the name of the cation, so sodium, you just take it as it is in the periodic table, and then the followed by the base name of the anion, and so chlorine has the base name chlor, and you change the ending to "ide". So the full name is sodium chloride. MgF2, another example. So you may recognize Mg as magnesium. That's the metal, so it's going to be the cation. F is the fluorine, it's the anion because that's the non-metal. So the name for MgF2 consists of the name of the cation, which is magnesium, just as it is in the periodic table, followed by the base name of the anion, fluor, and with the ending "ide". So the full name is magnesium fluoride. Let's go through another example, K3N. K is potassium, that's the metal, so it's the cation. N is nitrogen, that's the non-metal, so it's the anion. The name for K3N consists of the name of the cation, so potassium, followed by the base name of the anion, nitre, and with the ending "ide". So nitrogen becomes the nitride ion. And so the full name is potassium nitride. Another example with CaO. So in CaO, you recognize calcium, the metal, so it's the cation. O is oxygen, the non-metal, and then the anion. So the name for CaO consists of the name of the cation, calcium, followed by the base name of the anion. So oxygen becomes the oxide ion. So the full name will be calcium oxide. So let's practice that. I want you to pause the video before you watch the answer. It is important you try on your own so that you are actively learning. So let's start with the first example. Sr3P2. What's the name of Sr3P2? So Sr, you will find it's a strontium, and then P is phosphorus. So strontium is in group 2A. It's an alkaline earth metal. It's a predictable ion. It's always making a 2+ ion. So it's a type 1 ionic compound with phosphorus, the non-metal. So you just name strontium, and then phosphorus, you change the ending to "ide" and it becomes phosphide. So the name will be strontium phosphide. Li. So Li is lithium and I is iodine. Lithium is a type 1 metal because it's in group 1A. It's always Li+. So we will just name it as lithium, and then iodine will become iodide. You change the ending to "ide." So that's a lithium iodide. BeBr2. Be is beryllium, group 2A, an alkaline earth metal, so predictable, always 2+. Br is bromine. Br is bromine with the ending "ide", it's bromide. So it's a type 1 ionic compound, and so it's named beryllium bromide. K2O. K is potassium, group 1A, alkali metal, predictable ion, always +1. O, another predictable ion, it's oxygen, and when it's the anion, it's the oxide. So potassium oxide is the name of K2O. Now let's practice writing a chemical formula from a name. So you should be able to do the reverse process, which is if you have a name, you need to be able to write the chemical formula. The charges of the metal and the non-metal can be predicted by using the periodic table. So which group it is in is, helping you to decide the charge on the metal and the non-metal. So for example, if you have the name aluminum chloride. So aluminum is a metal. It's going to be the cation. And chloride is the non-metal. So it's going to be the anion. Aluminum is in group 3A. And chloride is in group 7A. So they are both predictable ions because aluminum in group 3A is always making a 3+ ion. And chlorine is in group 7A is, so for them, for the non-metals, you do the group number -8, and it's the charge. So 7 minus 8 is -1 for chloride. So the chloride ion is Cl-, and the aluminum is Al3+. So to write the formula, you need to place the positive ion first and then the negative ion, just like in the name, same positioning. So AlCl. Here you can do the crisscross trick where you take the charge number of each and crisscross it, and it becomes the subscript for the other element. So here the chlorine has only one negative charge, so it's going to be a subscript of 1 for aluminum, and the aluminum has 3 positive charge, so the subscript for chlorine will become 3. And so it becomes AlCl3. The subscript of 1 is implied, it's not written down. So that's the formula for aluminum chloride. So let's practice or let's look at examples here.